Welcome to today's video on section 3-3. We're talking about logarithms and basically how to translate from exponential form to logarithmic form and vice versa. So basically, if you see here, you have the base, which is b, y is equal to the exponent, and x is equal to the answer. So notice how it translates in the logarithmic. So for example, if you have 5 squared equals 25, then it becomes log base 5 of 25 equals 2. Right? Logarithms are always equal to the exponent. Here you have log base 3 of 1 over 81 equals -4. And then you can also translate the other way as well. So here, if I want to go from logarithmic to exponential, remember my base is 4, my exponent is 2, and that equals 16. Here it would be 3 to the x equals 8. So when you're looking to simplify, here this says log base 2 of 8. Well, you can just make it equal to x. So basically you're asking the question 2 to the x equals 8. Well, 8 is the same as 2 to the third, so x is equal to 3. Here, you're asking 3 to what power is equal to the square root of 3. Well, remember, the square root of 3 is equal to 3 to the 1/2 power. So that means x is equal to 1/2. Same thing here, log base 5 of 125 equals x. So basically we're saying 5 to the x equals 1 over 25. Well, 1 over 25 is the same as 5 to the -2nd. So then x is equal to -2. Here, if we put it equal to x, we're saying 4 to the x equals 1. Well, remember, anything to the 0 power equals 1, so x is equal to 0. 2 to the x equals 3. Well, at this point, we cannot make 3 a power of 2, so we can't solve this yet. But this one cannot be simplified. All right, because 2 is not a power of 3. All right, so next page talks about the basic logarithmic properties. And that is, the first one is that log base b of 1 is equal to 0 because anything to the 0 power is equal to 1. So anytime you have log base b of 1, so like for example, log base 5 of 1, that equals 0. Whenever the base and the answer are the same, because think about it, b to the first is just going to equal b. So for example, log base 5 of 5, that's just going to equal 1, because 5 to the first is equal to 5. Also, log base b to the b to the y is equal to y. So for example here, if I had log base 5 of 5 squared, that's going to equal 2, because 5 squared should equal 5 squared. And then the last one is because they're inverses of each other, and that is because, and that looks like this. If you have log base 5, actually, sorry, let me rewrite that. If you have 5 raised to the log base 5 of x, that's going to equal x. whatever x is. So in this case, like if you had 5 to the log base 5 of 7, that's just going to equal 7. So if these two are the same, then the answer is just 7. There is what's called a common logarithm. If you look on your calculator, that is when it's base 10. So if something just says log without a base, it's assumed that the base is 10. So some things like log 1. Well, remember, anything, log base anything of 1 is always equal to 0. But log 100, so basically you're asking 10 to the x is equal to 100. Well, remember, that is 10 squared, which means it's 2. Then you have the natural logarithm, which is base e, which is also ln. So remember, log base e is the same as ln. So there's assumed to be an e down there. That is the base. So when it says ln of the cube root of e squared, then we're really asking e to what power is equal to, now remember, when you have this kind of thing, it's power over root. So it's e to the 2/3. So then that means x equals 2/3. Alright, so now we're going to talk about how to graph logarithmic functions and just kind of review this. Remember that the base function here would be log base 3 of x, and remember, graphically, the base function, you have a vertical asymptote at x equals 0, and then you have the point 1, 0, and then you're going to have the point 3, 1. And there you go. There's your base function. So now we have our transformations. So remember here, this can be written as negative x minus 1. Because remember, you take out the number in front of the x. So there is no horizontal stretch or shrink. However, there is a reflection across the y-axis, and there is a horizontal shift to the right 1. There is a vertical stretch by 3. There is a reflection across the x. Reflection across the x-axis, and then there's a vertical shift up 1. So when we make our chart, you have the point 1, 0, 3, 1, and the vertical asymptote of x equals 0. Then you have negative x, you have x plus 1, you have 3y, you have negative y, and you have y plus 1. So it's going to go negative 1, 0, 0, 0, 0, 0, 0, 0, and 0, 1. Here it's going to be negative 3, 1. Then it's going to be negative 2, 1. Then it's going to be negative 2, 3. Negative 2, negative 3. And negative 2, negative 2. And then last but not least, here it's still x equals 0. Then it's going to be x equals 1. And the y doesn't affect the vertical asymptote. So when you graph it, your vertical asymptote's at x equals 1, then your first point's at 0, 1, and then you have -2 and -2. So it's going to look like this. And that is our graph. Alright, I hope you enjoyed the video for this evening, and I will see you in class tomorrow. Have a good rest of your evening.